record. My name is Wendy Alchua, and I will be addressing the misconception that 1/2 plus 2/3 equals 3/5. First, the Alabama standards that will be addressed in this video will be 5.NF.9, model and solve real-world problems involving addition and subtraction of fractions referring to the same whole, including cases of unlike denominators, using visual fraction models or equations to represent the problem. Use benchmark fractions and number sense of fractions to estimate mentally and assess the reasonableness of answers. And then 5.NF.10, add and subtract fractions and mixed numbers with unlike denominators using fraction equivalents to calculate a sum or difference of fractions or mixed numbers with like denominators. So I'm going to use these fraction tiles to represent my fractions that we're going to be using. Using these fraction tiles, it gives the students a chance to use hands-on as well as visual. So it's a multi-sensory activity, which will be more engaging for the students. Quickly with the students, I would review that fractions are equal parts of a whole, and that equivalent fractions are two or more fractions that have different numerators and different denominators, but are equal to each other. So all of these fractions here, 2/2 equal a whole, 3/3 equal a whole, 4/4 equal a whole. And we can see this because when we put the pieces together, they're the same length. So now to move on to the misconception, I'm going to use my 1/2 tile and my 2/3 tiles. And then I'm going to get my 3 1/5 tiles because the student said that 1/2 plus 2/3 equals 3/5. And so when we put our tiles together, the top row is what we added together, the 2/3 plus 1/2, and the answer, 3/5, is what's on the bottom. We can very quickly and easily see that 3/5 is much smaller than 1/2 plus 2/3. Something else I want to point out is that we can very easily see that our parts of our whole are all different sizes, and a fraction is equal parts of a whole. So we need to find some equal parts to add together to make our whole with equivalent fractions, fractions that are equal. So to begin with this misconception, or solving this misconception, I'm going to break my pieces apart, my 1/2 and my 2/3, and I'm going to start with fourths, and I'm going to try to build each of those two fractions separately. So I can use 2 1/4 tiles, and that equals 1/2. When I move that over to the thirds, 2/4 is not large enough to make 1/3, 2/3, sorry, but 3/4 is larger than 2/3. So even though I could use the fourths to make the half, I cannot use that to make thirds. Let's look at our 5th tiles. 1/5. 2/5 is not large enough to make 1/5. 3/5 is too large. So using these tiles, I can use trial and error until I grasp a better concept of making equivalent fractions. So now we're going to try with 1/6 tiles. Here's 1, 2, 3. 3/6 is equal to 1/2. Let's see if we can use the 1/6 tiles to build 2/3. 1, 2, 3, 4. I can use 4/6 1/6 tiles to build 2/3 or 2 1/3 tiles. So we've found our equivalent fractions. If you notice, Now, when we put them together, they are equal. And our pieces down here with our equivalent fractions are all the same. They're all 1/6 pieces. So let's write our equivalent fraction so that we can solve this, because 1/2 plus 2/3 is not equal to 3/5. So now that we know that, let's figure out what 1/2 plus 2/3 is. We're going to start by writing our equivalent fractions. Over here, our 1/2 becomes 1, 2, 3, 3/6. Here, our 2 1/3 become 1, 2, 3, 4, 6. Now that we have a common denominator, we can add our numerator only. So 3 plus 4 equals 7 over our denominator, which is 6. And we can see this when we put all of our tiles together, that 1, 2, 3, 4, 5, 6, 7, 7/6 is equal to 3/6 plus 4/6. So 1/2 plus 2/3 equals 7/6. I hope that this addressed any questions that you would have about the misconception of adding across and not using like denominators and equivalent fractions.